Okay, so in this video, we're going to look at the financial activity, okay? And the financial activity, it also is dealing with attributes of exponential functions. So let's go to begin. It says, suppose you received a gift of $10,000 and you want to invest it, okay? So you could say just from reading that alone, a good interpretation is that your starting is going to be $10,000. Okay, so it says you visit two banks and you want to see what they have to offer. Okay, Bank A, let's go ahead and do this in green. Bank A is near your home and pays 5% interest compounded, okay, annually. And then let's use a different color. Let's use purple for Bank B is further away from your home and pays 6% interest compounded annually. Then it asks, you do not think a 1% difference in rates is that significant, but you want to check. Okay, this is huge. Again, guys, we can't stress enough how real life application this unit is. Okay, so if you know the math behind it, you're going to make some good money. You're going to save yourself from losing a lot of money because you don't want banks taking advantage of you. Okay, especially when you go to college and you get these credit cards, you got to know this unit for sure so that you're not ripped off and in the regards of interest rates and whatnot. Okay, so calculate the amount of interest each plan will earn after 1 year. Okay, so we want to do after 1 year, we're going to record our answers on the lines below. Okay, so let's start with Bank A. So Bank A, again, we started with $10,000, so that would be my starting value. Then I'm going to multiply with, again, we got to start with that magic number 1, representing that 100%. And we're going to invest. And invest is adding, okay? When people invest, the natural default is that you're going to make money off of it. So it's going to be adding, so it'll be with a plus. One more time, remember our equation comes from the amount after a certain amount of years is equal to the starting principal times the 100% plus or minus the rate to the power of t, which is time in years. Because we are adding this investment, we would use the adding here and not the subtraction, okay? This is how you would talk yourself through this. So the interest rate that Bank A has to offer is 5% interest. Again, 5% as a decimal, you'd move the decimal over. So 5% is normally like this, if you will. And when you move the decimal over 2 times to the left, you get rid of that percent sign. Okay, so it'd be 0.05 as a decimal form. So that's what we're going to put over here in our equation. Okay, and we want to know after 1 year. So this is going to have 1, and now we're going to go to Bank B and set that one up. This one also is 10,000 because that's where you start from. 1 plus, but this one is 6%. So it's going to be 0.06. And it's also going to be raised to the power of 1 because, again, we're looking for after 1 year specifically. So we want to see what happens. What do these yield as time goes on? So you decide to calculate how long it will take each bank to pay $5,000 interest. Okay, you want to see when will I get $5,000. So this is extra money aside from your 10,000 that you're going to be getting. This is what you want to basically find out. So from these, Bank A, the amount of interest is not this. This is the total amount. If we want to know just interest from both of these, what this activity is asking is, after you've calculated how much that is, subtract it from your original amount. Subtract this from your original amount, and that will give you the amount of interest. And just the interest, okay? So for instance, let me go to the calculator real quick and show you what this is saying. Let's do Bank A, okay? So we'll come over here, menu 1.4 to clear storage, menu 1.5 to clear and get a nice clear screen. We're going to start at 10,000. This is bank A times 1.05. You can put 1 plus 0.05 if you want to the power of 1. Pressing up and pressing enter, if there are more decimal places, it will display them because sometimes it doesn't always display, but there aren't any, so that's okay. But if I subtract it from the 10,000 original amount, I see that I made $500. Okay, the total that I have after 1 year in the bank is 10,500. But what this is asking over here is after 1 year, I was able to make $500 from bank A. Okay, so let me go ahead and leave that in green, just so that you can kind of keep things organized. Okay, and if I wanted to know after 2 years, then I can come up here or type it all out all over again. I can change this to the power of 2. This is how much I now have in the bank. But if I subtract my original amount, we're going to subtract 10,000. It's now 1,025. Okay, so 1,025 is what I now have. So that's how much I've made off of just having this money in the bank. Just having money in the bank rather than underneath your mattress in your room. You know, underneath your mattress, you're not going to earn money. And you know the saying, money makes money. This is exactly what this is talking about. When money is in the bank, it is making you money with interest. Okay. So if I were to keep going on and on for, 3 years, 4 years, 5 years, 6 years, so on and so forth, there is a pattern to this. Okay. And you can already see that if I go up here and I change this now to 3, and I subtracted the 10,000 that I originally started with, now it's showing, again, let's see if there's more decimal numbers. Nope, not on that one. It's showing that it will be 1576.25. Okay, so let me go ahead and write that here. 1576.25. This is how much money we're just making. This is extra. This is money in our pocket. Okay, and we're going to round to the nearest dollar. So let me go ahead and change that just real quick, just to show rounding to the nearest dollar. This would be 1576. Now, real quick, I want to show you how you can program a calculator to kind of do all this for you, but you have to understand the math. Otherwise, when you type in the equation that you want to save program-wise, you're not going to know how to, you're going to get incorrect answers, okay? So here's how we're going to start. We started at $10,000. We know that it's accruing 5%. But the thing that's changing, the variegated variable that's changing is this 3. It went from 1 to 2 to 3. We could say, let's give it x. And we're going to subtract 10,000 from it. Okay, this is the pattern right here. This equation is the pattern each jump. So if I come over here and press Control vars or store, these blue letters are storing that function. I can store it. Let me do it again. I can store it as f of x. So after 1 year, and notice that it's bolded because it's stored as a function. Let's press Control Enter. I have $500. That's what we had way up here when we did it all by hand. I had $500 after 1 year. After 2 years, I had 1025. So let's press F of 2, Control Enter, and we get 1025, just like we did up here when we did it at 2 years. This was the total. We subtracted 10,000 to get 1025. And over here, this 1576 will be after 3 years. Okay, and this is what you get. Again, you have to know how to set up this problem here, this stored function. You have to know what is it going to take for me to get any value. And that's the easy part of from here, just doing what's f of 4, what's f of 5, Control Enter, what's f of 6, Control Enter, so on and so forth. So that you see 1576, 2155, 2763, since we're rounding up, 3401 since we're rounding up. Okay, so let's go over here and let's go ahead and enter the rest of these values. So we have 2155. Okay, we have 2763. 3401. For the sake of time, I'm just going to fill these in. 4071, 4775, and 5513. And all of this is extra money in our pocket simply because we had $10,000 in the bank at the very, very beginning. Okay. Now, if I did this with Bank B, a lot of it is the same. In fact, I could even go back up to what I have as a stored function, and I'm going to restore this as f of x. So it'll overwrite the f of x that's stored right now. And now f of x has been stored to where if I did f of 1, I would have this answer. F of 2, control enter. F of 3, control enter, so on and so forth. F of after 4 years, control enter. And then you see these values here. And I'm going to go ahead and write this in before I transfer over to the other screen. I have 600, I have 1236, I have 1910, 2625, because you're rounding to the nearest whole dollar. And you can see the numbers are different. It's definitely more money for sure. So for the sake of time, again, I'm going to go ahead and put these in: 3382, 4185, 5036, 5938, and then 6895. B is definitely the better option. One little measly percent more shows a huge difference in $5,500 after 9 years versus $6,800 after 9 years. Okay, so Bank A, it looks like it was about 9 years for it to get past this $5,000 interest that we were asking ourselves at the very beginning. Whereas Bank B looks like it was only 7 years to get to that $5,000 interest. So you say time is money. Time is definitely money here. So when we're putting them in, if we want to see the difference in interest, okay, of how much money was different, first of all, we can go over here to our graph, and we're looking at the difference between, obviously, the Bank B is the better option. You know what I'm saying? And after 1 year, it's the better option by $100. Okay. And the way that I got this $100 is I simply looked at Bank B was $600, Bank A was $500. And if I'm subtracting this $100 difference is what I just graphed over here in gray. Okay. So 1236 minus 1025, just real quick, 1236 minus 1025, we could see is 211. So the difference there is going to be $211, which is approximately somewhere around there. Okay, so let me go ahead and highlight that. About 211. And then the next one's about 334. And then we have like 470. Then we have like 620. And again, this is just showing you the differences between the better option and the worst option. Okay. So again, we are subtracting that B amount. We're subtracting the A from that. And the difference was for this one, was, let me go ahead and write this out, $100, $211, $334, $470, $620, and so on and so forth. Let me just finish this off, and then that's it for this video. So we have 784, which is let me get this straight line feature going on. So 784 is a little bit below. And then we have 965, which is about here. 1164, which is about here-ish. And then last but not least, 1382 was the difference between that last column. And let me go ahead and fill these in. So we have 620, 784, we have 965, 1164, and 1382. Okay, so obviously, right here, this difference, 6895 minus that 5513, let me go ahead and put that in, 6895 minus that 5513 gives you that 1382. Okay, so bank B is definitely the better option, and this graph shows you how that goes. And that's it.